In the 1980s, Microsoft released MS-DOS, which stands for Microsoft Disk Operating System. All applications that ran on IBM-style computers required DOS to be installed and targeted the DOS runtime environment. Any inter-application communication required public application programming interfaces, or APIs, normally involving hardware interrupts. In the 1990s, Microsoft introduced Windows, a runtime environment hosted on top of DOS. At this point, applications that ran inside Windows required Windows to be installed, or included a runtime version of Windows, but most people have forgotten, or would like to forget, this footnote in Windows history. Eventually, Windows became the operating system, no longer requiring the DOS runtime environment. Now, even though Windows itself hasn't required DOS to operate in many years, DOS does live on within Windows as the still useful command prompt that you can use to execute command line statements. But DOS is no longer handling basic operating system functions. Instead, the command prompt uses the Windows Systems API to perform its work. It's quite interesting how the two have switched roles during the evolution of Windows over the years. Now, at its core, Windows provides a massive collection of methods and data types as part of the Win32 API. And again, API is just the application programming interface. Early Windows applications made extensive use of this and related APIs to interact with the user and computer hardware in order to perform whatever creative features the application programmer chose to build. Over the years, this API has grown exponentially, so much so that it would be nearly impossible for any single programmer to understand it all. And it's a moving target, with expanded features to support all the new features added to every new version of Windows. Then, around the turn of the millennium, Microsoft introduced version 1.0 of the .NET platform, a runtime environment hosted on top of Windows, much as Windows used to be a runtime environment hosted on top of DOS. This platform acts as a convergence of several technologies into a single package that helps you build and run all kinds of software, including web-based applications, data management applications, and business or smart client applications. In essence, .NET has become the new Windows API, abstracting away the messiness of the Win32 API, and believe me, it's a really messy API, and providing features that are much easier to use from applications. Alright, so .NET provides a layer on top of Windows, so you don't have to deal with all of the messiness of the underlying Windows stuff. The Microsoft .NET Framework 2.0 was actually the third version of the object-oriented programming environment for developing applications ranging from command line to graphical user interfaces or GUI applications to web applications and XML web services. .NET Framework 3.0 was developed to work with Windows Vista and Windows Server 2008 operating systems. Version 3.5 of the .NET Framework was released in late 2007 and provided additional methods and properties not included in version 3.0. And version 4.0, released in 2010 in conjunction with Visual Studio 2010, provided even more features and enhancements. And version 4.6 of the framework is the current version, released with Visual Studio 2015 in, 2015. Each of these new versions of the .NET Framework introduces many new features to support new features in Windows, new technologies, and sometimes new application types. One of the best things about using the .NET Framework is that it encapsulates a huge amount of infrastructure needed by modern applications, including things like complex math operations, network communication protocols, data processing, cryptography, and much, much more. And the code is largely mature and well tested for you. Now, rather than limiting programming in .NET to a single language or environment, Microsoft made the .NET platform open, so you can program it with many different languages, including the two most popular, Visual Basic.NET and Visual C#. In addition, because Microsoft released the .NET SDK, or Software Development Kit, in a freely downloadable tool, you don't even need to spend money to create .NET applications. You can simply download the SDK and then use your editor of choice to create applications. Of course, you'll be a lot more productive if you use Visual Studio, as you'll see throughout this course. But there's no requirement that you use Visual Studio. And in recent years, Microsoft has moved to fully support open source software and non-Windows platforms. This means that many of the technologies that make up and are related to .NET have the source code available for you to inspect and learn from, discuss, and you can even contribute to it if you find a bug or think of a great new feature that everyone should have. The company also supports various initiatives to let .NET code and applications run on non-Windows platforms, particularly the Mac OS and Linux. Soon, .NET may be a viable programming environment anywhere that you want code to run. Okay, but why .NET itself? Before .NET, if you wanted to create software applications, you often needed to master the subtleties of multiple technologies and authoring environments. In addition, you needed to manually stitch the technologies together to form a coherent solution. So before .NET, creating dynamic websites required learning Visual Basic Scripting, or JScript, and managing the intricacies of mixing script and HTML. Creating high-performance database applications using SQL Server required learning T-SQL. Building business applications required learning Visual Basic. Automating personal productivity applications, things like Microsoft Office, required learning Visual Basic for applications. And building streamlined graphics applications required learning C++. And that's just a small sample of the kinds of technologies that you had to deal with. Now, Microsoft's .NET platform lets you accomplish all of these tasks within a single authoring environment using your favorite language with much of the behind-the-scenes plumbing completed for you. It's all built into the framework, so you can really focus on the interesting stuff of your custom application. So you can select either Visual Basic or C#, or a mix of the two, and can handle all the tasks involved in creating complete applications within the Visual Studio design environment. So there are a number of advantages to .NET. So Microsoft .NET provides remedies to all of those problems that I mentioned, okay, the complexities of software development before .NET. So some examples. .NET offers an object-oriented view of the Windows operating system by encapsulating many hundreds of the most important functions into what are called classes. Application security is built right into .NET, providing more robust protection than Windows default security. And the security model is independent of the version of Windows that's being used. Again, it's all abstracted away for you. Deploying applications is easier because of all the components of a .NET application. They exist in containers called assemblies. These containers can be deployed without the need to add entries to the system registry or install external components, although you can still do both those things if you need to. Versioning issues, which involves overwriting older components with newer components, a particular problem when multiple applications use the same components. Versioning issues become less of a problem using .NET because .NET lets you deploy multiple versions of the same assembly to the same computer and can manage version information for multiple versions of an application. You might have heard of DLL hell. That's largely eliminated with the .NET framework. Assemblies can be digitally signed. Using a technology such as Authenticode, users can see who authored the application. This helps users decide if an application is safe to install and run. Unless your applications incorporate legacy COM components, .NET applications don't need to create entries in the Windows registry. By avoiding the need to write information into the registry, your applications can manage versioning better and avoid possible registry corruption issues. Again, a big problem with the old DLL hell issues. And finally, all .NET languages are interoperable, meaning that code developed in one .NET language can be used and even extended in another .NET language.